And now, the first keynote of our summit. Join us as we explore the future of vehicle attribute development with Jonas Groetzinger, Head of Department and expert for vehicle dynamics at EDAG Group. In this presentation, he'll present the Zero Prototype Lab, a groundbreaking approach to facing the complexities of modern automotive development. Discover how EDAG leverages virtual function development and dynamic attribute testing to redefine the driving experience.
Yeah, thank you, VI for the nice introduction. And I'm very happy to be here today to talk with you about the complexity of the multi-attribute development in the automotive industry. Today, I want to focus on the challenge at the multi-attribute development and also on the solution we will provide for that. But first, what is the attribute development by looking on a vehicle? In our opinion, the attribute development show the DNA of the vehicle. So it shows the personality of the vehicle. And this can be clustered into 6 different attributes. The focus for today's presentation should be the dynamic attribute. So for this dynamic attribute, we want to generate a very nice and pleasure feel for our customer. So that means the driver satisfaction or the passenger satisfaction should be very good. And the people feel this by their sense. So the sense of balance, of touch, of see something, of hear something. And in the development of the attributes, we try to match this sense behavior to a specific attribute. For example, looking on the balance of the person in the vehicle, we can match directly the handling attribute. Or looking at the touch, we can match the steering feel, the pedal feel, and also we can interact directly about the ride comfort behavior of the car. Additional to that, we have the NVH behavior located directly to what we hear in the car. So that means the structural dynamics, also as well as the airborne noise, come directly to the passengers in the vehicle. And we link this to specific attributes. Looking on the process, how to develop those attributes, we start at a very early stage with a product definition. Based on this product definition, we generate a target set of the vehicle. And then we continue the development to achieve those targets until the start of production. After start of production, often we will have an update of the vehicle as well as an update of the dynamic behavior of the vehicle. And then after end of production, there's not so much to do in the attribute development until now. So that means the complete attribute development will be done in the initial stage of the development, where no prototypes are available. And this is the big challenge for us. Looking more into detail in this initial development phase, we start the development with a benchmark. So we grab different vehicles from the market, evaluate those vehicles, and based on those vehicles, we start the virtual development with different phases. And out of the virtual development, somewhere we will build the first mule vehicle, the first vehicle we can drive on the road. But the gap between starting the virtual development and having the first vehicle available to feel what we developed is quite long. After the mule, we have the prototype 1 vehicle, and at the end, hopefully, we get a prototype 2 vehicle, like a mass production car to do the homologation. So the target range for start of production is often set by the customer in the middle of this development process. So we have no cars available until starting the production of a vehicle. And that's a quite difficult thing for us. At the end, if we build such a vehicle, we develop such a vehicle, we build such a vehicle, then the customer can buy the vehicle, go to the road, and stuck in a traffic jam. So that means additional, to speed up the development time, the market changed completely. So to avoid those traffic jams, we can change the transportation system. So we can go more to public transportations, or we can share the cars to increase the capacity of our transportation system. And on the other hand, we can generate a transportation network system. For that, we need X-by-wire systems, steer-by-wire, brake-by-wire, drive-by-wire in the vehicles. And those by-wire systems have to interact with the autonomous drive systems. The combination of both of the maximum capacity and the network system generate the highest efficiency of our transportation system. And this is the future. And this future, we developed in a research project with the CityBot you see on the top. By developing this vehicle or this complete ecosystem, like the campus-free city ecosystem, we saw two major items for the development in the vehicle. One is the development of the by-wire systems. Such vehicles have a different configuration. They have different by-wire systems. In case of the CityBot, we have a steer-by-wire system with 4 steering actuators. We have a by-wire system for each wheel. We have an acceleration system for each wheel. So the configuration of the vehicle is very complex to handle. And this system is only possible to drive by an AD system. So it's not possible to steer each wheel individual with one steering wheel. So we need an AD system to drive such vehicles. And in fact, the driving function behind such a system is the combination of using both systems. So we have a complete effect chain through different systems in the vehicle to run a vehicle in a proper way. And that's very complicated. Additionally, when we build such a vehicle and we build such a driving function, then we want to go to the homologation, and we smashed into the legal framework we have at the moment. So in the legal framework, we have the ISOs, ECs, NCAPs, UNS. We have all those systems they are required to have in a vehicle. And additional to the systems required in the vehicle, we have cybersecurity, we have FUSI, we have SOTIF, so we have to provide the proper functionality of the vehicle and the phase functionality of the vehicle. And this can be done by the process supported like Pegasus, ASPICE, and so on. That means in total, we have 3 challenges for the attribute development in the future. We have to speed up the timing to develop connected driving functions, and this in a running, changing legal framework. So how we do this? We do this by using the RFLP for the development. So we developed function-based. And this function-based development, in combination with a continuous development approach, is possible to speed up the development time. Additional to this, we use the virtual testing to face the legal framework and to check all these connected functions. So to go this development approach, we have to change our process completely. And in our new process, the Zero Prototype Lab of EDAG is completely involved. You see here our location in Wolfsburg, and in the building in the middle, there is the Zero Prototype Lab located. And now you will see a small rendering of this prototype lab. So you start the rendering of the Zero Prototype Lab, and the Zero Prototype Lab consists out of 3 simulators from start on. The first simulator arrived us in December 2023, and it's a desktop simulator from VI-Grade. The second one we got last month. It's a FSS simulator. And you see here a picture of the simulator running now. And the third one in the Zero Prototype Lab will be the brand new DIM 500 simulator from VI-Grade with the complete hyperdoc Guido announced yesterday. So the combination of those 3 simulators is in our Zero Prototype Lab available. The current status of the laboratory is like this. So the FSS simulator is available and ready for usage. And we build at the moment the DIM 500. So the moving platform is on a base plate, and we will finalize the build of the DIM 500 during the next 1 to 2 months. So that means in July, the laboratory is available and online with its full configuration. So that means our solution to achieve the attribute development is that we start at the initial phase with a benchmark, and we bring this benchmark into the virtual world. And from that on, we can continue directly in the combination of the simulation with driving the vehicle in the DIM 500 and driving the vehicle on the FSS simulator to get directly an impression back from the driver's behavior. And this loop, we can go continuously. So we can update the mechanical items on the car, we can update the hardware in the car, we can update the software in the car, do the handling, steering, ride comfort, NVH evaluation again, update the parameters, update the functions, and go into the next loop. And we can do this for the mu phase, we can do this for the initial prototype 1 phase, and at the end, we can go directly with the prototype 2 to the proving ground to do the final tuning and the homologation. So this is our solution to face the complexity in the multi-attribute development. So that means we link the human sense directly with 2 different simulators to have a feedback from the initial development of the vehicle. And that's our approach for the multi-attribute development. So you're very welcome in our new Zero Prototype Lab from June on, or from July on, to see the DIM 500 and the hyperdoc and the FSS simulator in combination. Thank you very much.